Presenting Falcon C2 Universal Eddy Current Inspection Handheld Instrument. Power-up sequence is short, under 9 seconds, and immediately ready for inspection, providing increased productivity. Last setup is automatically loaded, and instrument is ready to continue inspection where it stopped in previous shutdown. High-frequency eddy current inspection is the most used NDT method in aircraft maintenance. We start with probe selection. In this method, we use a pencil probe. Probe selection configuration is followed by a long press on the balance center button. Selection is possible in more ways: touchscreen, slider, or keyboard. Proceed to calibration, angle, or rotation of liftoff first, then adjust gain to achieve 100% screen height response. Screen grid, origin position, and persistence can be adjusted in the Settings display menu. Origin has 2 predefined positions, while persistence and grid spacing are continually adjustable. Low-frequency eddy current inspection can be used when increasing multi-layer structures or looking for errors on the far surface of the material. Setup is similar to high-frequency inspection. The calibration block used is different in the placement of errors, which are on the back side of the calibration block. To achieve a good separation between liftoff and crack signal, XY separation is used. As usual, calibration block material is within 10% conductivity value of inspected material. Eddy current array probe is used to obtain a C-scan of inspected material. Device setup is simplified and consists of probe selection and calibration, which has 3 steps. First, hold the probe in the air so the instrument can learn the first point for lift-off compensation, then the second point on material, and finally normalization of C-scan representation by use of standard calibration notches and screen cursor. After calibration screen, representation of errors is consistent. Inspection of holes with rotating probe is of particular interest in aircraft maintenance. It usually takes place when skin repair is necessary with the use of a large number of rivets or primary structure in aluminium material, but also in steel when inspecting, for example, engine mount. screen representation has a time amplitude and amplitude phase graph with the possibility to adjust gain phase. Thresholds and alarms can be adjusted separately for the left and right graph. As seen on amplitude phase representation, 6-figure filtering is used. Weld inspection using Initec-developed Weld probe shows that reliable detection of cracks in welds on penetrant and magnetics inspection blocks is possible. That allows for a quicker and more reliable method to be used without extensive preparation necessary for other surface inspection methods. A special probe developed in Initec laboratory is designed to minimize the lift-off effect on the uneven weld surface. Conductivity measurements and non-conductive layer thickness measurements are part of the same entity method. The instrument setup begins with probe selection, followed by calibration in 5 points. Air, 2 conductivity calibration blocks, and 1 known non-conductive material shim in combination with conductivity calibration blocks are selected. After calibration, we can check the accuracy of measurements on all conductivity samples and non-conductive material shims. Device with Wi-Fi and web browser, mobile phone, tablet, or PC can be used to access embedded Wi-Fi access point and remote device functionality through Falcon Manager.